Okay, so for those of you who don't know me, there's a few here that have worked with me before. I'm currently the CTO at Cashworks. I was the CTO at LawPath for 3 years, which is 3.5 years, which is where I first started building serverless applications. So that was 4 or 5 years ago. So I'm going to talk today a little bit about why I started building serverless applications, what we did. I'll also talk a little bit about why not. When would you not want to use serverless? What are the downsides? I'll talk a bit about, this is the slide that I didn't add, about things we learnt and things that if you are going to try and build serverless apps, you probably should be aware of. Some things that might take you a little bit of time to work out if you're not aware of it. And then I've basically just got a diagram of very roughly our sort of architecture, and I'll talk through it a bit. I'll try and finish relatively early and leave space for questions. Literally, why serverless? So when we first started out when I first started out on the journey of building serverless apps, I was at LawPath. We had 2 developers. We couldn't afford DevOps people, we couldn't afford sysadmins, we didn't have those that sort of capability. There was literally like 6 of us in the company. And so one of the drivers was to be able to build applications that didn't require me as a CTO to have to go and spend money on hiring a DevOps person or hiring DevOps people, or hiring people with sysadmin skills. I've been around a long time, so I've got some. I've got enough to make me dangerous, but I didn't want to have to build that capability inside the team. And that's pretty much still the case today at Cashworks. It's something that by using a serverless architecture, we don't need as much of that capability. We don't have to worry too much about the setting up load balancers and having to worry about auto scaling groups and all of those sorts of things. We leave that stuff to Amazon. And so a big driver, one of the bigger drivers at the time, was just trying to keep my team as small as I could and focus on development in terms of building features that were going to satisfy our customers, rather than having to invest some of our the funds that we'd managed to convince our investors to put into the company and have to spend that on things like sysadmins and DevOps. So that was pretty successful. It was still a reasonably steep learning curve, because we, at that time, when I started off in LawPath, I inherited a Rails app, and it wasn't a particularly well-written Rails app, and we sort of started from scratch. We moved from that into using an Express app on Heroku, which I'm sure other people here have done before, maybe still are doing. But when the time came to sort of move beyond that, and that application, that sort of monolithic API became a bit too big and a bit too cumbersome, we decided to switch to Node and switch to Lambda functions and learn how to build a serverless app. So one of the other reasons that we switched to serverless, which I'm sure many of you would think is a key reason, was cost savings. So thinking about how much does it cost to run an EC2 instance or a set of EC2 instances where they're doing practically nothing a lot of the time. Our application servers might have been doing very little, but we're paying for those to be up, whereas with Lambda functions we're paying in 100 millisecond increments. And so we're only paying when our functions are actually executing. And to give you some idea of the impact that has, at Cashworks, we've got quite a lot of stuff. We've got some existing, more traditional architecture, and we've got a platform which I'll talk a little bit about which is based on serverless. Our total Lambda costs for probably last month, if I think about last month, for our development environment, our staging environment, our demo environment, and our production environment was about $56. So, when you switch to that type of model, and it's really dependent on the type of load you've got. So when I go on to why not serverless, if you've got a really constant load where you've got processing happening all the time, yeah, maybe Lambda functions aren't the right solution for that. But I'll get onto some of those things. So cost is definitely a factor. It was one of the drivers. Ooh, that moves. It was one of the drivers for at LawPath. Again, as a startup, you're trying to do things on a shoestring and the smell of an oily rag. So a serverless architecture is perfect for that type of environment. There are some downsides which I'll talk about. For some companies and some use cases, those downsides are, yeah, okay, I can live with that. For other circumstances which might apply in your cases, those downsides are just showstoppers. And so you need to actually understand what those things are in order to decide whether this makes sense or not. So one of the other drivers for serverless is scaling. So it's mentioned sort of load balancers, auto scaling groups, the stuff that you have to worry about if you're going to run a scalable EC2 based architecture. One of the benefits of using Lambda and using API Gateway and using some of the other service-based technologies we use from AWS is that I let them worry about the scaling. That's not perfect, I will say. Yesterday we had some issues with step functions just taking a really, really, really long time to execute. So again, some of the downsides that I'll talk about can be, it would be really nice if you had perfectly consistent performance all the time, but where you're offloading a lot of these responsibilities to AWS and saying, you guys worry about scaling and you guys worry about firing up containers and shutting them down again and executing my functions, there's a cost that comes with that and you need to know whether that cost is okay for you. Scaling, auto scaling, and being able to rely on Amazon to handle that for you is another important aspect of serverless. Have I got a timer anywhere? Where's Daryl? Sorry? Okay. Yeah, right. Okay. You guys like this? Is this good? Is this okay so far? Yeah. So why not serverless? Because I've alluded to some of them. Serverless is not a silver bullet, right? Serverless architectures are not right for everything. And particularly if you've got those sort of really consistent loads where it's much more cost effective to run an EC2 instance with a reserved instance pricing. That's much more effective. But where you are looking for, I think the word agile tends to get overused. I prefer to think about being responsive to what the business needs. Maybe if I were to go back, another one of the reasons I use serverless, and in particular the sort of Lambda functions and that, and I guess that there's an overlap there with microservices and that type of architecture as well. One of the massive benefits of going down that path is you can change things faster. You can implement new things faster. You can change things that didn't work faster. You can throw stuff away and it doesn't really matter. You can, I can talk to my sales guy that comes back from a meeting with a super fund and says, oh, they really, they want to do it this way. And I can sit there and say, oh, yeah, okay, well, if I did this and I did that and I created this new function, I can deploy that. I could probably have that API done by maybe tomorrow afternoon. And it really helps in terms of agility with being able to deploy things quickly, being able to change things quickly. So that's another reason for me why it's beneficial. But in terms of why not, so who's actually using the Lambda service? Who loves the cold startup time issue? So those of you who aren't aware, when you deploy your function into the Lambda service, the first time it runs, the service has to actually fire up a container and load your code and execute your code. Now, I don't know about you guys that use it. Sometimes we see maybe 8 or 9 seconds for a Lambda function to actually execute the first time, which is pretty shit if that's your authentication and someone's trying to log in, right? Because it makes your application look really bad. So, you know, we all come up with these strategies for sort of hitting those Lambda functions to just warm them up and make sure they're loaded. Once that container is fired up and your code is loaded, then the next execution is going to be really fast. So, but this cold start issue, which I'm sure everyone that's using Lambda, it's you know, a pain in their neck. I'm told it's going to be fixed. I'm still waiting. I was waiting for an announcement at reInvent, but it didn't happen. So, but that cold start issue is a significant issue. And that's one of those ones where if that matters to you, if that's a showstopper for you, then that's a reason why you would say, no, serverless isn't for me. But if you can deal with it, if you can do things like, you know, hit those Lambda functions to warm them up, but you know, that in itself can be a bit annoying because I'm going to hit a Lambda function and potentially get an error because I'm not really using that function, I'm just sort of waking it up. Then it starts to pollute my logs in CloudWatch, and that becomes really annoying. So you've got issues like that. There are other sort of practical development related issues. So for those of you who are using Lambda, who's using serverless? Actuals like serverless.com serverless to the serverless framework. So one, other people are using different things, using the Amazon solution. So because I started a long time ago, that didn't exist. I can't remember when that was introduced, but you know, I first started using serverless. The serverless framework, if you go to serverless.com, when it was at about version 0.9 or something like that. So there wasn't a massive benefit for me to sort of go, oh, well, Amazon have come out with a solution, I'll just throw all of that out and start again. But one of the things, the little things that you will find as you go, as your application gets bigger, you'll come up against some limitations of CloudFormation, for instance. So you may start off with one project and you'll start adding functions, and you'll get to a point where you've got so many functions in your API project that you start getting CloudFormation errors because you've exceeded the output limit on CloudFormation. So then you'll break that down, probably, split that off into individual services. So in our application, for instance, we've got, I think, about 9, if I remember correctly, 9 or 10 individual services. Collectively, I think there's about 108 individual functions distributed across those services. And you can use features of the API gateway to make it easier to you know, set up your API on a custom domain and use custom base paths so that you can, for instance, say my domain /users/ whatever. And those are the sorts of things you start doing, breaking down into services. If you want to call them microservices, that's fine too. But you will strike things like those sorts of limits. Has anyone struck the maximum, hit the maximum limit for code storage in Lambda? No, you haven't got that. So there's you can store a maximum of, I think it's about 75 meg of code, actual code in a Lambda function. Or actually, I think it's in your region. I think it's in the region. So you have to be careful because every time you deploy a function, Lambda will by default create a new version of that function, but it'll keep the code for the old one. And when you get to version 120 of your function, you may have, particularly if you're using Node and you're bundling, we use Webpack to bundle our dependencies when we deploy. So every code deployment might be like a 3 or 4 meg bundle that gets deployed. It doesn't take too long if you've got a lot of functions to get to like 75 meg, and then you can't deploy anymore. So you need to be aware that that's a limit. There is a plugin for the serverless framework for pruning all those old things and saying, oh, I only want to keep the last five versions. So there are little traps like that you will come up against, and it'll be the time when you're trying to fix a bug and it's a massive production bug and you've just got to deploy this one change and you can't deploy it, which happened to me probably about 2 months ago. And that's the time where I discovered that particular problem. Of course, it was when I had to fix a production bug. So you get sort of issues like that. Other reasons for not using serverless, and this is maybe as much a microservices issue as a serverless issue. What you save in terms of the complexity of your big monolithic API application, you sort of pay back or lose in terms of, I've got all these nice little simple little functions that are deployed, but I've got like 100 of them, and understanding how they all interact and how they talk to one another, and am I using SNS or am I directly invoking one Lambda function from another Lambda function? Making those sorts of decisions you can get to a point where keeping all of that in your head and remembering how this whole thing works can be interesting. So that's I'm not sure that I'd say that's a why not, but it's something to be aware of. So there's a really high level rough configuration of some of the bits that we use in our application. So we're a typical web application. We're loading in this case it's a Vue.js application. We're loading direct from S3. So if you've got a static a single page app and you're not deploying that into S3 and serving it through CloudFront, but you're serving it from a EC2 instance or something like that, I'd suggest you look at this. So we just deploy our front end application straight into S3, load that through CloudFront into the browser. So this is a fairly typical model for your service application. We're going to deploy APIs on the API gateway. In our case, for each environment, we've got 9 different APIs, each of which has somewhere between 5 and 15 functions deployed, so endpoints. There's a lot of detail that we can sort of put in there. I've glossed over a lot of the detail. In terms of authentication, those of you who've used API Gateway will know that we can configure our API endpoints to invoke a Lambda function, which is a custom authorizer. So before it actually hands off the job to the Lambda function, which is serving the endpoint, we can invoke a custom authorizer, which can verify, for instance, the token. Let's say you've got you're supplying a token with the request after you've authenticated. We currently use Cognito for authentication. I haven't got anything more to say about that. But you may be supplying a token. You can implement a custom authorizer, which can verify your token, but also do things like verify authorization to the endpoint that you might be trying to access. Get through that custom authorizer, it generates a policy, passes it back to the API gateway, and API gateway will then, let's say I've got a get on, I'll talk REST rather than like GraphQL, but let's say we've got a get on, I don't know, let's just say /user/ID. So I'm getting the details for a user. We'll invoke an individual function here, which potentially is going to go and hit your database. Now we use, in this architecture, we use a graph database called Neo4j. So we may go and get our user details from the database and feed that back. We've got the application that we built here is very workflow oriented, and so we've used step functions. So I guess what you notice from this is that we do not have in this architecture one single EC2 instance that we manage ourselves. Yeah, there's EC2 instances that might be run. Our database is a service, so clearly that's deployed onto EC2 instances, but we don't manage them. Our Lambda functions are all individual functions that are deployed into Lambda and get executed based on the API rules. There are some Lambda functions which are not part of, if you like, part of the API. They're not invoked by an API endpoint, they may be invoked by an SNS topic. So we use a lot of communication, particularly between our REST API and our workflow that's implemented in step functions. There's quite a lot of SNS communication, so we've decoupled our workflow from our REST API. What else? So step functions, if you haven't used those, are a great way to capture state machines. They work quite nicely. We've had like really minor issues, but in general, we use step functions really heavily for our workflow. So what I might do, because I think I was given the 5 minutes about 4 minutes ago. So I'll stop there and say, has anyone got any questions? Because I'm happy to sort of try and address particular issues. So I'm going to go ahead.
Have you ever run up in any issues with the initial concurrency limits? Or could you see, so I think it's 570?
Yeah.
Can you repeat the question?
A lot of very spiky requests. You could actually get to the stage where it can't fire up new instances quickly enough.
Yeah, so the question for those who couldn't hear is, have we come up against any problems with the concurrency limits? So basically in the Lambda service, you deploy a function, Lambda will auto scale it'll fire up that function as many times as it needs to a limit. And so the short answer is no, we haven't encountered that. But I guess the longer answer is you need to understand the nature of your load and the nature of, so for us, it's not a very spiky load. It's actually very, we will, our load, because it's sort of a fintech, financial, we're talking about sort of a daily cycle, we know we will get load, or we get load at sort of around 11 in the morning. Most of our load is sort of between 11 and 12, because that's when term deposits in the super funds and the sort of big end of town, that's when they're making their decisions and processing their orders. But it's pretty low load from our point of view. That's why it's so cheap for us. We're not paying to run EC2 instances when we're not actually doing anything. So it's not a problem for us. I don't anticipate a problem for us. The sort of instances where it might become a problem for us, so I was actually looking at reconciliation today. So if I were to say, I'm going to take all of my investing entities from my database and say, right, go and reconcile that against another system, and I just fire a whole bunch of things off in parallel, then I might encounter that limit. And I guess my default answer is I deal with that from a code point of view, because I'm the one creating the load. So it's quite predictable. Does that answer the question? Any others? I think you're next. So the question was, have we started using layers? So layers were only sort of announced at reInvent this year. So the short answer to that is no. We use, as I think I mentioned, we use Webpack to bundle all our dependencies at deploy time. Is it worth it for us to actually sort of refactor to introduce to set up the layers? Probably not. One of the gotchas that might be an issue with layers, I think layers would be great if you've got a really good understanding of what your dependencies are going to be. But if you're in a sort of development phase, particularly with Node, and you're going, oh, I need that thing, I'm going to pull that in, I don't want to have to go and rebuild that in order to add that to my layer. So no, and at the moment, I don't anticipate that we will, unless we come up against a problem that's going to sort of drive us in that direction.
One more question.
It's getting cold.
I didn't even see it come in, sorry.
Would running greengrass on an EC2 instance solve the problem of the whole Lambda APIs? Because then you have your critical ones that are always on your instance, that are always ready to go, and you can always migrate it off there later. So
the question was, would running greengrass on an EC2 instance sort of mitigate the cold start problem? It might. I'm not really too familiar with with Greengrass. But for me, the issue with that would be I don't want that skill set. I don't want to complicate my architecture. For me, I'd rather, unless I get to a point where it was really a problem for me, it's easier for me to just write something that just hits the Lambda functions I really care about, like auth, and just wake them up. And for us, as I said, our load is pretty predictable, so I know when I need to wake them up. I don't have to have something that's sitting there hitting them like once every 20 minutes or whatever to keep them awake. I can say I know these fund managers are going to log in at maybe 10 to 11, and so it's a lot more predictable. Other circumstances you'd have a different solution, I think. Okay.
Cool. Let's everyone give Peter a hand. That was a great talk.
We spoke a lot about serverless tonight, but is serverless only about Lambda? What is serverless? So serverless is when your cloud provider manages your service for you. That's the concept. However, you can run more than serverless you can run more than Lambda in a serverless model. So tonight I'll not talk about, I know the title looks like that, but I'll not talk about how to do CI/CD for Lambda. Instead, I'll talk about two less known services, Amazon Fargate and an external service named Alert Milpa. Back in the days, or maybe not so much for many people, it was common to provision a set of EC2 instances. And then you configure them with Ansible, Puppet, or your beautiful handcrafted bash script. And later on, we start working with cluster orchestrators, such as Jenkins, pretty much everyone knows here, later on Kubernetes, Hadoop, and many others. And the goal of these orchestrators is to make our cluster more dense. They allow us to run more applications per instance, so that you can run more workloads in our cluster at the same cost. And if we need more capacity, what do? We just create an auto-scaling group, so that when the CPU, memory, or any other threshold on where it comes over, the CloudWatch will then trigger a creation EC2 instance. This EC2 instance registers with the orchestrator, and then the orchestrator can deploy the workload there. Pretty easy, right? Not so quick. It quickly takes a large engineering team to manage this pet shop. You might call it DevOps, Ops, but it's a pet shop literally because you have a cluster that you need to manage. And those doing it know that our cluster is always too big, and then we are wasting resources, so we have the financials complaining to us, or it's too small, and then you need to wait that some other people job terminate, or that we have some availability, or that someone actually goes and provision the machine manually if it's still at that stage. In addition, you also need to manage the cluster. That doesn't mean just to deploy the cluster. That means that you have to patch and configure your operating system, your Jenkins agent, Docker, or your applications running there. And if you have a static cluster, that means you have to shut down the cluster, or at least shut down one node, don't be crazy. Shut down that node, update that node, and then restart it and have it running again. And this might mean you have some workloads to go down for a period of time, and all this takes a lot of time. It gets very, very tricky on the issue. We heard about Amazon Fargate before. Cool, it's a lot of people for a year here. Who is using it? Nice, that's very interesting. Who is using ECS, Elastic Container Service? Okay, all good. If you're not familiar with the topic, let me explain quickly what is Fargate. The idea of Fargate is, why should you provision these fleet of EC2 instances to run your containers? You can delegate that to Amazon. So this was how Fargate was born. Fargate is Amazon managed container platform. With Fargate, you just have to build your container, your Docker containers. You have to publish, and then you define ACS, Elastic Container Service task, choosing what's the name of your Docker image, how much CPU, how much memory do you need, and then you invoke ECS. But ECS will then invoke Fargate behind. So we'll invoke Fargate saying, please Fargate, run this container for me, so that no one has to manage the service to do that. And Fargate will then provision the resources and run the container seamlessly. So you don't have to see any EC2 instances showing up on your dashboard or caring about doing configuration of that. The only thing you have to do, as always, you have to pay per CPU and per memory, but you only pay for what you use. You don't have any static resources there. And Fargate adoption is rising so quickly that in the last year, it already accounts for 6% of the container environments running on Amazon. It's quite interesting because it maps more or less for the hands up here. Well, Fargate allows you to run containers. Milpa allows you to run EC2 instances as well. And why Jenkins? Because the principles are the same of having an orchestrator. So in this example that I'll show you today, I'll show you how can you keep interacting with your existing application orchestrator, for sake of demo Jenkins. But instead of scheduling a new node, instead of scheduling the job to run in existing nodes in your cluster, Jenkins will invoke Milpa. We'll invoke this tool here. And then Milpa will be responsible for provisioning your EC2 instance on demand to run your job. So I call Milpa a serverless engine. It pretty much allocates EC2 instances, network load balancers, etc. on demand to run your application. And unlike most parts of the orchestrator tools, it doesn't aim to run multiple containers in the same instance. It runs one container per VM, or one application per VM in this case. And it creates a EC2 instance, deploys your workload there, and then as soon as your workload terminates, it shuts down that instance. And this allows you to start using, as someone was saying in the presentation before, it allows you to start using EC2 instances as well. So it allows you to start leveraging GPU, network enhancement, and also leverage a price that EC2 has, so on demand, on spot prices. And so you're not constrained anymore to a CPU and memory kind of price model. In addition, if you notice on the slide before, if I don't have any jobs, that means I don't have any nodes actually running. And so from a licensing point of view, that means that I don't have as many nodes online, so I don't have to have as many licenses as I used to need before. And the VM isolation allows to extend beyond containers. So because you run a VM per workload, you can run other things rather than containers. You can run jar files, you can run AMIs, you can package your application in whatever way you want, and that system will simply deploy that in EC2 instance. And also a very good advantage of that is that sometimes that's a requirement for multi-tenant environments. The people don't want to share the same machines. Later in this presentation, I will show how the community is starting to overcoming the overhead of having to run one kernel and one VM per application. Small tip on that, that's also related with Lambda. So people who was paying attention to the last re-event will have a guess on what I'm talking about. Before the part that everyone is excited about, demo. So in this demo, I will build a Golang container using Milpa. The process will be as follows. I will update my master branch that will trigger a Jenkins job, and then Jenkins will invoke Milpa. Milpa will create EC2 instance, build my container, and as soon as my container is built, it will terminate the EC2 instance. So, fingers crossed, let me show you how this will look like. Can you still hear me if I talk at the moment? Oh, good. So, here we have the EC2 panel, and you can see that you have not much happening here. We have two nodes at the moment. We have Milpa, which is as a server that's pretty much orchestrating everything. And we have a node. This node here is a Jenkins master, so it's a permanent online Jenkins master because you need to expose an API. What I'm going to do now is I'm going to go to this project here, and I will just do a change. Another one codes using BigWY, but just for sake of the speaker. I will merge it to master. I also don't do this at home. It's incorrect to do this. And this will trigger a Jenkins job. So this job, if demo goes on with me, here we go. The job starts here. It's the job number 33. And what this job is going to do is invoking Milpa. And Milpa will start the EC2 instance to run this. Let's see how this works under the hood so you can have a better idea of how these things plug together. So we didn't do the plugin, we just created a script for Jenkins. And here we go. This is a script. Long time ago for many people as well, I understand that feeling. So what we do here, so the key part is what we do over here. So we are defining a manifest file, saying that we want to run EC2 instance with a certain amount of CPU, memory, and volume size. And Milpa has a cost optimizer that will try to find what's the best instance type to run this and what's the best cost. So if you want to enable on spot, you can also do that to get the best prices. We pretty much say Milpa create this pod. We wait until the pod starts, until the machine starts. And in this particular scenario, we're gonna be tarring, create a tar file with the Jenkins workspace, so all your Jenkins workspace, and we send that package to run in EC2 instance. Then, further below, what we're gonna do is, okay, I need to run this Go build, and for those who use Go, you know that you need to have tooling to do that. So how can you get the tool there? The way you get the tool there here is we use an image, which is a container image, that contains all the Go tools that allow to run Go-build, Go space build. And as a parameter to that, we run a command, so it can be anything that's defined in Jenkins, and we mount the file that we sent before. And this allows you pretty much, when you apply these, once you apply this and you apply the manifest, this runs the workload in the EC2 instance, builds your container, and we just have to wait until that finishes. And once it finishes, the Jenkins job terminates. So by now, we see that the EC2 instance that we created before, which is C5 large, is already terminated. It's running already another C5 large to do the deployment pipeline. But yeah, pretty much the script we saw before already executed. And as you may see, this took us a couple of minutes. So we don't have to have this machine up and running all the time. This is my personal account. I'll not be happy to have a C5 instance running all the time. So let me show you a bit about this command line tool that we have in Milpa. So Milpa CTL, for those easy to Kubernetes, something newer. Much to do here. Yeah. So this allows you to create Milpa objects, allows you to create workloads that will be then deployed into its instances, allows you to deploy packages, so if you need to ship some packages to the instance, exec to access the machines, get the machines that are running, getting the logs, update, and getting the usage, which is interesting as well because you can see how you can see the costs of running this. So Milpa CTL get. Well, in here you can see that we had a couple of pods running before. Maybe too much pods. So you have 3 pods, one of them being terminated already. And every time you launch a pod, Milpa will allocate load balancer as well for that, so you can expose the service if you want. And then using Milpa CTL usage, you can see a report, and there's more subcommands to do this. You can see a report of how much instance you are using, how much storage, and how much networking you're using. So you have a kind of a cost panel to manage this. And the cool thing of this is, as you saw, we had to modify the Jenkins job to run in this serverless model. I didn't have any machines running there. I modified my Jenkins job to invoke Milpa, and Milpa handled all the creation of the service, everything else for me. And I can do this transition from a static cluster to a Milpa or serverless cluster as I feel comfortable. I just modify the jobs as I go. Now, for people asking why in hell we're talking about check-ins and not about Kubernetes, which is what everyone uses at the moment, I would say. Fargate and Milpa, both of them can integrate with Kubernetes. When you invoke Kubernetes, you just use the API, and then the API, which is an orchestrator, will invoke kubelet, which is an agent running in each of the nodes. And that agent, which you call kubelet, then calls Docker, which will gonna run your container. And it does it through an interface that we call container runtime interface. So there's two main ways that we can extend your existing Kubernetes cluster, which has all the bash scripts now to invoke Kubernetes, to use this serverless model. The way you can do is using a virtual kubelet, so stubbing over here, or creating a container runtime interface, so you're stubbing in this way here. The first approach, using a virtual kubelet, is an approach taken by Fargate. So for a Kubernetes cluster ETS as well, running based on Fargate, the Kubernetes control plane will invoke a virtual kubelet, not a real one running in EC2 instance. And this virtual kubelet pretty much transpiles the instruction of create a pod to an instruction in Fargate of run a container for me to have this pod running. The second approach is to use container runtime interface. And here we are studying not the API that Kubernetes uses, but an API that Docker uses. So container runtime interface is just an open source name for the interface that Docker exposes for that API. So what happens here in this situation, using Milpa, the kubelet invokes Kiot, which is a stub built by Milpa, and then this stub will invoke Milpa to run the container. So kubelet will say, please run Docker image X, and then Kiot will invoke Milpa, please run Docker image X, and Milpa will say, okay, cool, I need to create a new EC2 instance because that's the size of the container that you want. It's gonna schedule the container to run there, and as soon as the container is over, it terminates the instance, so you don't have to pay forever for this. And this allows you to start benefiting from serverless model outside of your common environment. So last one on this. So in the last re:Invent, Amazon announced Firecracker. Did anyone heard about that before? Amazon. So Firecracker is a very, very interesting project. Please go online and check it. Firecracker idea is to be a lightweight hypervisor. So it's kind of a stupid version of a QEMU KVM. So the goal of Firecracker is to allow you to bootstrap a VM in a fraction of a second. So you don't spend 30 seconds until the boot starts. It's a fraction of a second it starts a VM. And do that by making things as lightweight as possible. They have like 4 virtual devices on it, for instance. And so far, with Lambda, it's been running inside of a container, as mentioned in the first presentation. Lambda runs inside of a container. That container runs inside of the EC2 instance in your account. With Firecracker, Amazon is moving towards a model of micro VMs. So it's a micro VM that is created in a large set of metal machines that are shared across multiple tenants. And inside of that micro VM, managed by Firecracker, will run your Lambda function. And what happened is that with this kind of approach, I really expect to see the problem that we are mentioning in the first presentation with Lambda to start fading away because they are addressing that with this project. And considering these projects such as Firecracker, gvisor, Kata containers, and others, I expect to see in a short, medium period some migration towards a model where we're going to have a kernel isolation again. So we're going to run a VM per workload, either an old EC2 kind of instance or maybe some new kind of EC2 instance that will be faster, bootstrapped, will be more designed for this kind of workloads. And this aligns with Milpa vision, as I explained to you, of having an EC2 instance per workload. Nevertheless, the main idea that I want to traverse here is that you can use serverless outside of Lambda. So you don't have to be constrained to using API gateway and Lambda functions to serverless. If you want to start delegating your workloads to your cloud providers, you can also use Fargate to do that. You can also look at platforms such as Milpo to do that as well. And they'll give you some extra level of flexibility, and will also help you to save a lot of money and costs. And they'll also avoid you to have your typical DevOps workspace where you have a set of machines running and you need to pet them. And we also enable you to do what the cloud is designed to, which is we need to run something, we provision at the moment, run that workload, and turn it off. Yes, you may face some limits on how much instances you can run, but that you also can update the soft limits without any problem. But that's exactly the vision of cloud. If I need a computation resource, I provision it, I run it, I destroy it. I don't have a pet store of clusters that I need to keep running to make everyone happy. And see these as a complement to Lambda. If you need to run something that takes more than 15 minutes or needs to run inside of a container and you don't want to hack Lambda to do that, use it. So now we can have a full serverless environment. And thank you for joining. I hope you enjoyed. I'm looking for your questions now. I'm sorry if it's too many new concepts or too many new projects in the same slides, but please go ahead.
Yeah, before when you use a JP, did you use a specific image to run that had the software preloaded, or you run project and install software on the fly?
So, very good question. So we don't use any image in advance. So there is a base EMI that Milk will provision to you, which is configurable. And then what we did is we package the Jenkins workspace. And the only thing I added to that was I have my package with the workspace, which contains my artifacts. And then I created a Docker container and attached that and run it that. And the only reason I'm doing that is just for sake of practicality, because it's much easier for me to run the container instead of having something that will fetch the binaries that are needed, so in this case the golib, and merge it with the workspace and then package all that and then send to Jenkins. The idea here is that you can run anything that you want within that EC2 instance. So you're not limited only to containers. If you are limited only to containers, then you're probably better using Fargate only, because that's what it was designed for. But if you want to have more flexibility and if you want to start using EC2 instances, and if you want to have some degree of control of that, and if you want to leverage other kind of EC2 instance types, such as the one that is GPU, then this platform is more adequate for that. Does that answer your question?
Yes, yes.
All right. You have first?
Yeah. So going by the script which I mentioned, Jenkins pipeline, it was using Kubernetes under the API 1 version. So I'm just wondering, is that a path? Is that kind of a requirement being changed? Just and scroll up a bit.
Yeah.
From here. Yeah. So is this kind of necessary because in our use case scenario, we might not be able to run on top of it's modern. So the challenge brings the challenge of running some of this like a native database build or something out there. So is that something we can release with this
Yeah, very good question.
Can you repeat the question? Sorry.
I can repeat the question. Yeah. So the question here is, I got exactly the same question before coming here from my workmates. So the question here is this actually a Kubernetes definition? And you need to run Kubernetes and running containers to use this framework. And we try to make the manifest, this YAML file, to be as likely to Kubernetes, but actually it doesn't need Kubernetes. So this is not running Kubernetes at all. The only thing we did was, okay, let's try to find an API that people are using already, and so that they will not have so much impact when they start using this service. So if I'm using to use Kubernetes, I know more or less this structure is how it looks like as an YAML-ish file with API version, kind pod. So you don't need Kubernetes at all on this. The Kubernetes talk in the end is just a different approach to all this. So if you want to run in a different orchestrator, that's not only Jenkins. But for the use case where you have Jenkins, for instance, you don't need any Kubernetes running. The only thing you need is to have a package, and you need to run that package in EC2 instance during a short period of time or during half an hour, 1 hour, and then you can do that. So anything, jar, WAR files, AMIs, another VM instead of the VM if you use bare metal machines. So we'll be fine, yeah, to address your use case.
Yeah.
But it's not Kubernetes, definitely not.
I have one more question. So one of the reasons why I have personally not invested more in Fargate is because the cost of it is super expensive at the moment compared to other platforms. So I noticed that when you hit that deployment, it's one of the instances pretty rapidly and familiarly, fairly in harmony in the range of 60 seconds, which is the first billing cycle. So in production, have you guys noticed any advantage of this? Because this is going to be definitely cheaper and slow and fun, and this turns it into against AWS kind of different.
So yes, it does. So
Repeat the question.
sorry, go ahead. So thank you very much for doing that. So the question is, how does this compare? How does Milpa compare with Fargate regarding costs? To a certain extent. So the Fargate model is a CPU and memory, and it's static. The more CPU you need, the more memory you need. You pay is X times time, pretty much. And Milpa tries to change that. What we do is we create machines that can be typical EC2 instances, which are far cheaper than Fargate. So yes, it's definitely designed for that. In addition, you can also have spot instances to run these because they are a short period of time, so they become far more cheap than using Fargate. Yes, that was one of the main reasons why the platform was designed. Someone had a question as well. Thank you very much. Okay, one. Sorry?
Is Milpa open source?
Now, at this stage, Lambda is not open source. The team is still working on the project, but please feel free to reach me and to talk about the project. But yeah, it's not open source at the moment.
Cool. There you go. All right.
Thanks very much, Derek. You're welcome. Give him a round of applause. That brings us into the educational section of the night. I'd like to now open up the floor for people who haven't got a job and are looking for a job. Is there anyone that's bold enough to come up and just say what they're looking for, what their skills are? Because there's probably an employee here at least, not Joe Jones as well. So yep, please come, take it forward. It's not meant to be like a big thing, but yeah, line up, come on, you want it. No, just in the mic so we can hear. Yeah, so it's 2 seconds about who you are, what your skills are, what you're looking for.
Sure. My name is John Wheeler. I'm an ex-AWS technical account manager. I've left AWS looking for a new opportunity as a solution architect, something a bit more hands-on than a TAM. Came to Oracle before that. From Oracle before that. Thank you. Whoa, we have a winner. So yeah, anyone else? My name is John. Please come and see me afterwards. Thanks.
Thanks, John. Next.
So I'm Chandan. I've started with development, and right now I'm into technical pre-sales. I also did technical manager roles. Actually, I'm very nervous. I said technical pre-sales. I don't present. I make presentation for my solution architect. Have you seen this? Big Bang Theory. There's this guy who cannot, speak unless he's drunk. I had 2 beers, so I can talk. But the funny part is, leave that aside. I have all 3 AWS associate level certs. I'm really interested in AWS, learning better, learning more, and doing solutions for people, for companies, and just reach out to me on LinkedIn. I'll leave.
It looks like this, so come talk to me afterwards.
Yeah. If you want to talk to me, just reach out to me. Thank you.
Cool, thank you. Next up, let's go to the crystal ball. I like it.
Hi everyone. My name is Khaled Bouhari. I got here from Israel a couple of months ago. I'm a security architect with hands-on experience in AWS, everything cloud, infrastructure, application security. One of the leaders of the local OWASP community in Israel. We do conferences of 700 people each year. 12 years of experience in the field. I'm starting a small boutique security company, and I'm looking for some contracting gigs, penetration testing, secure architecture, secure assessments. Thank you very much.
Cool. Thank you. Any more takers? Yes, one more. Why not? Put your hand in the ring.
Hey guys, my name's Sam Anthony, and I've got about 12 years experience as a back-end software engineer. But in recent years, I've been breaking out into sort of managing cloud infrastructure and developing web applications on sort of serverless framework, and sort of really, looking forward to transitioning more in that direction, and also obviously sort of emerging in DevOps responsibilities as well.
Cool, too easy. Well, thank you. Right, that's all for now, yes? Okay, any employers looking for employees? No bosses here? No? No, sort of? Okay, good. All right, well, that's that part of that. Okay, so on to the final thing, the door prize for the shoot. So probably some people left as less getting started, so I've got a few names that I will call up. Hopefully one of you guys get here still. Okay, is there a Negan or Randy? So Negan, I'm not sure I said that right. N-E-G-I-N, am I saying it right? Is there? Okay, cool. You're the winner. There you go. You want to come and get the prize? The camera and take a look. I'd like to thank our sponsors, Fortinet and AWS. They make it all possible. A round of applause for AWS and Fortinet. I'll drop the mic now. Right, well, that's pretty much it for tonight. I hope you enjoyed the talks. Come along to the next meetup, first Wednesday of every month. Do join the meetup, because this may be at AWS next month. It may not be here, so do look at what the meetup says. Feel free to stick around. There's not many beers left, so everybody go home now. All right, thanks for coming, you all. Bye now.